Hello and welcome to IT Security Labs, and thank you very much for joining me tonight. Give me a thumbs up if you can hear me. It has been a couple of weeks since we met, but I'm very excited to be back because over the past couple of weeks I got some rest, and I'm also excited to share with you this journey that I've been going through. So last week I saw that there's this wonderful vulnerability called Dirty Cow, and I didn't get a chance to work on it or even try it out. Dirty Cow is the same as the newest one from this year, 2022. It is called Dirty Pipe. A couple weeks ago, I showed you how to use the Dirty Cow vulnerability and also how to detect it. And this time, we might as well complete Dirty Pipe, which is a very wonderful and interesting vulnerability as well. So thank you all for joining me. And as always, my name is Howard, and I'm very excited today to be part of your journey as well as share with you my learning journey. This is what we usually do on this channel. I try to share with you what I'm learning, how I'm learning it, and how I'm becoming better as a cybersecurity person. For me, I have to hack myself if I'm learning these things. So one of the things that I do is I share with you what I've learned the week before. This is how I've grown over the past 7 years working in IT and moving into cybersecurity, and I'm hoping we can continue to grow together. So if your main goal is to be good at cybersecurity, please join me in this journey. Thank you for the music reminder. Thank you. Yeah, so today we're going to enumerate a Linux machine. We're going to find out what services are running on it. Then we'll identify that there's a web server there. We'll find a username and password on that machine. Then, of course, we'll do some privilege escalation using Dirty Pipe. So all this is going to show us Dirty Pipe. But what I found out the moment I moved into cybersecurity from being a sysadmin was there is no value in you knowing how to run exploits, point and shoot, without understanding what those exploits are doing, and also without understanding how you can defend those exploits. So we'll talk about our defense. Can we identify the attack? How can we identify it? What kind of rules do we create? And can we actually work on those rules together? And I have everything set up here, and I'll show you one of the many ways you can detect this. So I'm very excited about that. But before we get started, very quickly, just wanted to say, hey, if this is your first time on my channel, my name is Howard. I'm one of the people that I think have been able to move into cybersecurity by virtue of just learning and being motivated. If you are someone who is highly motivated, coming from an industry that's not even cybersecurity or IT, I think that you are going to learn a lot by just hanging out with me on this channel. Most of what I know comes from me just working in IT and learning by myself. I do not have any formal education other than these certifications that you see here, the OSCP, CISSP, CES, CH, and CCNP. Most of these certifications I got them at work, or some of them I paid for myself, like the CCNAs that you see here. So I'm very excited to be sharing with you as I grow. And one of the things that I always like to show you is the network diagram. I always find it easy to understand what's happening when I can see it. So here's a lab environment, which you can set up by yourself, by the way. You can go to the internet here, which is my home internet. And then we have a UDM Pro firewall. This is the main firewall for the lab. Here we create different VLANs and different networks that we monitor. And also we have an intrusion detection system here. I don't show you this one here because it manages other networks than just this lab. But down here on this VLAN, the 192.168.38 network, we have a Kali Linux machine, which I'm going to show you and I'll be using. And we have an intrusion detection system. This is the secret sauce right here. We have a layer 3 Unify switch. It does drop packets. Some people have reached out to me like, hey, are you actually sending 100% of the traffic? It does drop some packets, but it's not significant enough. So we are taking a copy of everything that's coming from our attacker, who is already on our LAN, by the way, and going to any of these machines here. I even have a Splunk instance that I'm not using today. But today we have a Windows 10 machine client. This one is running Hyper-V, and this machine here on Hyper-V, we're running a vulnerable machine. So I want you to know that it's a Windows 10 machine running Hyper-V, and we're running a vulnerable machine on this one. So every time we send something from Kali to go all the way down to this machine, Security Onion intrusion detection system gets a copy, and that's how detection is going to be working for us. So with that, let me show you what Security Onion looks like. So this is our Security Onion intrusion detection system. It's already collecting traffic, as you can see. We have seen some events. I have a couple of views that you can see here, and also a lot of alerts. The machine that we're going to be using to be able to detect is going to come from hackmyvm. It's called Pingme. So it's from hackmyvm Pingme. There's a link to the machine in the description. And when I put that machine on my lab, I think I have an IP address of, I already tried to access it on a browser here. Give me 1 second. 192.168.38.178. So if you download this machine, you can put it on your local environment, which I can show you how to set up. I have videos that will show you how to set up the network. And then in this case, the machine's name is called Pingme. Well, might as well ping the machine, right? It asks for a ping, we give it a ping. It does respond to ping. But this doesn't help us as an attacker. So you're given an IP address. You show up at a customer environment. They say, hey, can you do a pen test on this IP address? What steps can we start by doing? We can start by doing some enumeration. And I have to say this right now because I've been doing these live streams for a few years. And what I found out is that I run nmap like this, minus SV, minus SC. Okay, this will do top 1000 ports, and this is an nmap scan. There's nothing wrong with running nmap, right? But let's say this was a black box pen test. This might not be a good idea because you're going to trigger all kinds of alarms on the network. What do I mean by that? Let's just run it right now. I'm doing just the top 1000 ports on my victim. I'm already on the network somehow, or I'm scanning a public IP address if you're external. By alarms, I mean, I'm running a regular nmap. I'm not trying to hide. I'm not trying to pretend that I'm something else. If I go back to my Security Onion here, let's just do last 10 minutes. I'll move myself. Notice what happened. In the last 10 minutes, we got these alerts here. If you have been following along with me for a long time, you know these are coming along because we ran nmap. You only run nmap in its default form if you are not afraid of getting detected. In this case, we want to make as much noise as we can and learn as much detection as we can. So, of course, we're going to run nmap with the default switches. But what I learned very quickly is if you run nmap like this should be considered gross negligence if your goal is to hide. I wouldn't run nmap with these switches if I didn't want somebody to catch me, because this intrusion detection system here proves to me that anyone with an intrusion detection system with default rules will catch you. So would you run nmap if you are trying to do a black box pen test? Maybe not. So we have port 22, and this one here tells us the version of Debian that we're running. So you can look up for any exploits that may be available for this version of Debian. OpenSSH always exposes that. But we are more interested in port 80. That's what we see so far. In a normal environment, I will also do this. I will add another P here. So while I'm interrogating port 80 with its Nginx, I'll probably run a full TCP scan. And then I'll come back. If I don't find anything on these two, I'll come back to the full TCP scan to see if it found something. If I don't find anything on the full TCP scan, I'm going to move on to a UDP scan. And that's the order that I do things. Usually I don't find a lot of things on UDP. Most of the time, at least in these CTFs, TCP is enough. But of course, if you're being thorough for a customer, you'll probably want to do UDP as well. So I'm not going to do a full TCP scan. I think 80 is going to be enough for us. We already have a version of Nginx. There is a vulnerability for this version of Nginx. And we can do, maybe, let's do a search exploit. I was going to do a Google search, but let's do search exploit because that's better. Maybe we'll get lucky. So search exploit will tell us if there is any vulnerabilities for that version of Nginx. This case is saying there isn't any, but it's always not correct. So okay, so for at least for my local version of exploit search exploit, I have 1.17 and I'm on 1.18. So according to my local version, it doesn't think there is. But of course, my Kali hasn't been updated in at least a month. So I would come here, type exploit. There is an exploit for that version. You can read about it. The Nginx HTTP request smuggling attack. This one actually doesn't help as much. I looked at it. It's not a real legitimate vulnerability that we can gain access to the system. It's a vulnerability, but not to the extent that we want today. So we'll move on from what we just saw there with search exploit. Next, we will go and find the website. We just open a browser, put the IP address. It's on port 80 anyway, right? So if I refresh this, watch what happens here. We get the results like pinging this from this IP address. So it looks like it's a pinging utility. You visit a website, it pings. In the real world, is anybody going to have a website that will ping something for fun and just display results on the screen? Maybe not. But are there websites out there that will run commands on the command line on a system? Yes, there are. So I think the same applies. And this is how I learned ethical hacking from like the damn vulnerable web application machine. You had command execution directly on the terminal. So what this shows me is the system is actually running a ping command and presenting it back on the screen. Well, one way to think about this is we have to have access to that system, right? Somehow we're getting to the command line of this system. That's a fun thing to think about. There's only one way this can happen, right? We need to be authenticated to be able to run a ping command, or at least the application is doing the ping command for us. That means that somehow there is a ping happening on the application. I like to run burp suite to capture these requests and watch what's happening. I will skip that one for now and opt for tcpdump. Since this is a ping usually there is no encryption that I'm expecting to be happening with the actual ping commands. So I can do a tcpdump and watch what's happening here in real time. So let me wait for this one to be done. But burp suite is by far the best tool to use here. So to do a tcpdump, maybe let me come back here and say, what options do I want? I want, I don't want file size. I want -I for interface. I think my interface on this network is ETH0. Yeah, so this is my interface on this network. And my IP address is 192.168.38.176. So I need to put ETH0 there. All right. V for file, timestamp. I have a cheat sheet command that I had to find the exact commands that I need to be able to capture this. So let's see. Okay, I can say I want ICMP traffic, because I mean tcpdump will catch a bunch of things here. I only want ping traffic, so I want ICMP traffic. I would like to save it to a file called maybe capture. Hey, tcpdump, listen on ETH0 give me ICMP traffic, meaning ping traffic, and let's have a file called capture. Let's see if this one will work. All right, so tcpdump is like, yeah, of course we'll listen, and if we see any ICMP traffic, we'll let you know. We need to generate the ICMP traffic by refreshing this page and going back to tcpdump. All right, so it will listen. I did not put the verbose flag here. I didn't see it here, but we should have seen at least like the verbose mode. But I think once this is done refreshing, which it is done, we can stop it. Let's see if we actually have our capture. So our capture is a file, and it is actually a small size. So what I'm going to do is I already have a capture identical to what I just showed you here in Wireshark. So if you open Wireshark, you go to File, Open. If you go to Capture, it's the same exact file. And I liked this machine because being able to be able to work with Wireshark and being comfortable with Wireshark is one of the best things that you can do for yourself. I come from a networking background myself, and understanding what's happening on the wire has always paid off dividends. Those who knows what's going on the wire and those who can program or code are the most powerful people, at least in my opinion, when it comes to doing investigations on also attacking things. Because you need to know, what am I doing on the network? How can I automate things? I think those two. So if you look at this one, these packets, you notice that it says username right there. It says username. This is not comfortable to look for most people. So what I did, okay, I think I see a password now, but I don't know what I'm looking at. So what I did was, okay, let's click on this, expand on the ICMP protocol, right click, and say, hey, show me the packet bytes. So this is a packet byte that just says username. I'm hoping the next ones will show me what the actual username is. So I'll close this one, go to the next one. I think this one is doing the same. It's asking for a username. So let's look on the third one. So if I see something that's not the same information, then that should be the actual content. So now, right next to the username packets, there is this pinger. That shows me that the username that we are using for ICMP traffic is pinger. So we can document this as, this is my username, pinger. All right. So let's go to the next one. So the second one is also the same pinger. This is the one that says password. So I'm expecting two of them because that's what it looks like. That's the crazy stuff that's happening here. This one also says password. The third one, I should see the password. So show me the packet bytes, and here's the password. So far we've not done anything unique. We just opened Wireshark, captured some packets, went through the packets. Is this intuitive though? Do people just say, hey, I see a tool that is doing ping, I'm going to capture packets and watch what they're doing? Yes, people do look at packets. People do want to know what happened. So Burp Suite and Pickup are going to be your two best friends to tell you the story. And the good thing about this is you are an IT security person. They hired you to tell this story. They hired you to identify what happened. You're not going to show up to work and they'll be like, hey, here's a username. What we're just going through right now is say, hey, we just captured the requests that are being sent to the website, and we found out a username is pinger, and this is the password. We found out from a pickup. Most of the time, pickup is going to be your last resort. You don't start with pickup. You start with other indicators out there. But in this case, we captured it. We could have done the same with Burp Suite and found out the same information. So what do? SSH. Oh, how did I even think of SSH? Our results showed us that we had port 22 open. So that's why I said let's just SSH as the user that we found and the password that we found. So it's 192.168.38.178, I think. Let's verify that. Yeah. So for the password, we just copy this one here. So right off the bat, if you were here for like 10 minutes of this live stream, you already know how to capture traffic using tcpdump in real time. You know how to read that traffic using Wireshark, which is a very important skill. And now we're in the machine. This wasn't the main part why I chose to do the live stream. This was a means to an end, right? But as you can see, right away when I sign in, the banner of the system tells me, hey, it's Linux Pingme. So this is the version of Linux that we have running. It's Debian 5.10.9.2. Great. So we already know the operating system that we're working on. While a lot of people in the CTF and exam like OSCP world will shy away or will talk down kernel exploits, I found out very quickly that these kernel exploits do matter because they happen all the time. You are going to have people with old systems where you need to do a kernel exploit. If you are a CTF person like I was for a long time, you would think that there's no honor in using kernel exploits. If you are a CTF person like me for a long time, you would think there's no honor in using C2 like Metasploits. But let's be real here. Attackers are lazy, and the easiest path to an exploit, the better. And because their goal is to not be a stealth. Their goal is to actually get there and achieve their objective. So in this case, we have Debian 5.10.9.2. But let's say you don't have a banner like this one. Maybe they disabled it. You can say uname -a. I think you get the same information. So we get the same exact information that you see right here and right here. So right away from this information, you can go and look for any kernel vulnerabilities. I still think that it's important that you reserve them for later. Do silly things like sudo -l. I don't think anybody in their right minds are still doing this, but people do this all the time. Here's a way for you to get root. That's very easy. This binary here is running as root. You go and interrogate the binary, find a way to abuse it, and you get root. This is by far the easiest way. Because of that, I'm not going to do it because we just have to figure out how this tool is sending ping and capture more packets, go through more packets and reconstruct them, and we'll get root. But I'm more interested in what if you did see Debian 5.10.9.2? What do you do? What if you didn't see a binary running? Because a lot of people nowadays, they're smart enough to not do this. What do we do? You can go and plug this one in Google. Or you can do a search exploit like I did earlier. I don't think it worked. My search exploit doesn't have Dirty Pipe, but you can do something like this if you didn't have internet access. It will tell you like, hey, we don't have any exploit. Or you can go and look this one up on Google. When you do, you might not find something right away, but with the knowledge that we have, Dirty Cow and Dirty Pipe are known for affecting old kernel versions of Linux. So you will find yourself reading an article like this one from Datadog that says, hey, on March 7, 2022, there was someone who publicly disclosed a vulnerability on the Linux kernel. It was Max Kellerman. And then they named it Dirty Pipe. So we're like, okay, this doesn't help us much. Does it affect our version that we found? That's all we care about. If this doesn't apply to the version that we're talking about, it might be good next time, but not today. Well, it was fixed in these versions here, right? On the closest one to us is 5.10.102. Well, we are 5.10.92. So Does 5.10.92 fall in that version? Let's find out. So the first kernel that was known to have this vulnerability was 5.8. So we're at 5.10. The ones that they fixed were 5.10.102. By process of elimination, we fall in the range of when Dirty Pipe is vulnerable, right? So because of that, we know, okay, they fixed it here. So we are in the range between 5.8 and 5.10.102. That means that we should try Dirty Pipe. But hey, before you go anywhere and think, oh, this is how we're just going to fix it, there is a catch. There is definitely always going to be a catch, right? And I'll show you something that I think as you do your own attacks as well, you're going to find out. I found out very quickly when I was compiling this binary here that it's not that simple. Okay, so from reading through this, we know we are within the range. Dirty Pipe can be tried here. It's not guaranteed, but we should try. Kernel version 5.10.96 is vulnerable, and it's more recent than 5.8 and older than that. Okay, so which systems are we talking about? We have Debian system Ubuntu, so we are in the range as well. And how it works, here you get all the explanations that you get, and this is especially interesting for Docker containers. If you find yourself in an old Docker container and you do a uname -a and you see that the kernel version falls within that, then you can try Dirty Pipe and you might be able to actually get a privileged permissions, because this is an underprivileged container. So there is that part too that is very exciting. All right, so we established that we can and we should do it. How do we do it? If we go back here, let's just say, hey, I don't know how to run Dirty Pipe. Okay, I see one here. I like GitHub because then it's in real time. You'll be able to tell right away if things don't work. So here's a couple. Okay. It says to install GCC, then compile and all that stuff. We're not going to do any SUIDs. Let's try the option number 1. So what you do is maybe, let's say, git clone this repository. Okay. So type git clone. You need to have git installed on your Kali, which I hope you do. And you just type that CVE in the name, hit enter. I already cloned the repo in my Pingme machine. So you end up with a folder with the same exact name as the actual exploit. Okay. When you go in that folder, you are going to find that we have this compile.sh, and in this case I have a file called exploit. Let me remove that exploit for now, and let's say, okay, is our compile.sh already an executable? Yeah. According to our executable? Yeah. According to our instructions, let's compile it. If you do this on the latest version of Kali, this is why live streams are kind of cool. Because if you try to do this on your own in a heavily edited video, you'll be banging your head on a wall wondering what happened. Well, first, I got this error. And I was like, oh, what are you talking about? Okay. I was like, well, if I do an ls, I still see my exploit here. So what's the logical thing to do? Let's get this exploit to the machine. Let's do an HTTP to server on 80. All right. So I'm hosting an HTTP server here. And my IP address is 192.168.38.176. So what we should do is, let's go to the temp folder. Why the temp folder? Because everybody can write in the temp folder. Okay. So if I go to the temp folder here and I do a wget on HTTP 192.168.38.176. All right. I just got my exploit. So we need to give it executable permissions, you know, the good stuff. Watch what happens when we try to run it. This is what distinguishes people who are like, hey, I just point and I shoot, to people who kind of, you know, have done it things a little bit more. People who have practiced. Watch. The exploit tells you to go pound send. I mean, what do you do at this moment? Do you like just give up? Because your whole goal was, let's run the exploit. You can do something like this. Copy this. Ask our good friend Google. Find some solution maybe from some forum or Reddit. You spend, you know, a good 15-20 minutes here trying to get this one done, right? But I'm going to tell you what I found, because I did the same thing. I was like, well, what's happening here? Why isn't it running, right? This exploit should work out of the box. It's complaining about GLBIC 2.33. And I think that same forum that I put up is actually the one that told me what's happening here. It wasn't Stack Overflow. It wasn't Reddit. I don't think it was GitHub either. All right, I found it on one of these forums. But here's how you find out what's wrong with what's happening here. So remember, we compiled our exploit on our Kali Linux, and we moved it using Python simple HTTP. Well, here's what's happening. If I do LDD -- version, I want you to notice this is the same software that they're complaining about. I'm running 2.338 on this one. And this is what people don't tell you about hacking. They're like, oh yeah, you can just be a hacker, and you face stuff like this, especially for the OSCP. Like, you compile all you want, it doesn't work. You need to fix some binary or something, and this is exactly what they do to you. So it's 2.33 on my Kali Linux. Let's ask the same question on our system where we're running the binary. And someone is probably thinking, well, can I just maybe compile it on the system itself? I think that's a very good thought. So the same command on the victim is running 2.31. Kali, where we compiled our exploit, is running 2.33. So of course they already have a problem. Versioning here is a problem. So if you say which GCC, you got no GCC. As an attacker, you're thinking, well, can I just install GCC? But let me know in the comments what you think. Is it smart for you to be installing tools like GCC, wget, and curl on your victim machines, especially if you're trying to be stealth? Should we just go and just grab GCC and install it on our victim? Or is there a better way that we can do things like this? I chose to not install GCC on my system because I was like, well, I'm not about that business where I just download it, whatever is needed, because that increases my chances of getting caught. So what do? I spin up another machine. This is a different machine than Kali. This is an Ubuntu machine that I have in my lab environment. So I have a third VM. This one happens to be running this binary here on 2.27. Quick reminder, the victim is running 2.31 and it didn't like the one that I compiled with. My Kali Linux is running 3.33. So I have a third machine that's running a lower version than both of them. Or ideally, I want my compiler to run identical to 2.31. I couldn't figure out how to do that. So I was like, well, I'll just try. Can I just compile on a lower version of this binary? If you're looking at this, you're like, all that work just to do privilege escalation? I think it's worth it because what you get is you become root on this system, right? And you're just trying things out. So because of that, I actually ended up, let me show you my history here. I did a bunch of other things. Maybe the history won't show you it fast enough. But I have the same exact Git repo in here. And I was like, okay, let's just compile it again the same exact way. And I ended up with this exploit here. So let's bring this exploit to the victim instead of the one that we brought up. So Python 3 -m http.server 180. All right. So here we go. Now we have a separate VM with a lower version of whatever the binary that exploit was complaining about, hosting on port 80. The one thing I didn't do is I didn't check the IP address, but we'll find out. So, but we need to go back here and say, we don't want this one. This one doesn't work anymore. But we're going to keep our wget command. Instead of 176, we need this one. This machine was being used for Splunk and other tests that I was doing. So it was just a victim of my own test. I have a snapshot of it. If it broke, I would have gone back. So this is on 49. Let's launch our HTTP server. Going back here. So instead of 176, let's put 49. All right. So now we have a new exploit. Let's make it executable. So this is our new binary now for our Dirty Pipe exploit. Just like Dirty Cow. All right. It's as easy as that. So I know, I acknowledge that I did not tell you what we did, how the actual exploit works, which I think is one of the most important things we should cover. But I was able to follow a simple proof of concept from GitHub and get it to work. It's very important that I try it, and if it doesn't work, then I move on, but at least I tried it. So far, it's set up the root password to Aaron. I don't like that. Root ID. Okay. How about we make it more interesting? Let's change it right now to a very simple password. Oh, wait a second. So we just changed the password for the system. Hey, I did this on purpose twice because we have an intrusion detection system here that's watching. This thing better not be so dumb that it can't even catch a simple password change, right? this is host-based intrusion detection system. I should have at least a log that says somebody touched something on the system, because I'm monitoring, by the way, I didn't tell you this at the beginning. I'm monitoring everything that's happening there using audit D, which is an auditing tool. And I'm sending the logs here. So at least I have one here that says write access to Etsy password in the last 10 minutes. And I have an alert that says Dirty Pipe privilege escalation exploit was ran. This is what we are here for. How do we know that Dirty Pipe was ran? Is it some simple binary hash match that happened here? I'll show you in a little bit, but we got an alert that says, hey, Dirty Cow was ran. And we also have an audit. We're watching Etsy password. And it told us, hey, Etsy password has been touched. So let's find out actually what happened here. All right. So it actually tells us in detail, which I'll show you how I was able to set this one up so that I can actually get. But this is, we're watching the Etsy password file for any write permissions or any modifications to it. And it all ends up in this log file here, file log audit.d.log. I mean, audit.log. They should have said audit D, because that's the name of the service. So we can tell we do get alerts. But hey, we are root now, and we change the password. I mean, we can do an ls and cat root.text. But I think we have grown past the idea of celebrating flags. We're still fascinated by what happened. I mean, this is a great flag. Thanks to the creator for this. I like the flag. Let me validate that my password is actually working. For persistence, hey, persistence is kind of cool, right? Switch user to root, which will also, by the way, get logged. If you pull this command here, especially if you do a sudo su, you will definitely get logged if they have audit D in place. So let's put our password that we just created. So we can switch user to root. So if we wanted more persistence here, we can put maybe an implant that always, persists with the system or all those good stuff. But for now, I'm okay with this one. The one thing that I will also add here, there is a file. I don't know about that. Let me know in the comments if you agree with this model. I was going to say there is SSH open. By default, SSH does not allow root to log in with password. I was going to edit the SSH config file and allow root to sign in with a password. Let me know, for those who are here, what you think about that move. It's a decision that I was about to make right now. Can you and should you go and modify the SSH config file to allow root with root password once you get root password? And is that a good decision from someone who is trying to do a black box pen test or a red team engagement? You let me know. I'll move away from that for now, and I just hope that you can at least let me know. But for now, we have at least that in the works. I would like to come back and say, okay, the one thing that I mentioned is we got an alert that says, hey, we have a Dirty Cow privilege escalation. I'm going to add value to your life by showing you exactly how I did it. Because I think this also brings us to like no more like capture the flag kind of people, but now we're actually real world kind of people. Okay, first, this is the alert that fired. I had to create this. I actually kind of modified it a little bit. I borrowed everything that I saw here. Well, I only did one way, which is using audit D. Audit D is really great for Linux. You can install audit D on a bunch of Linux systems and actually have it watch security events and whatever is happening. It can be very loud though, especially if you tell it to log too much. Like, every time somebody signs in, audit D can tell you that somebody signed in, even though SSH logs can also have the same. But in this case, we use audit D. I followed exactly what they had on this documentation here from the wazuh documentation. The best way for us to detect this privilege escalation, I just posted a link to it, is for us to watch the actual agent. So I'm not adding more value than this article would, except I'm just explaining how things were set up so that if you're setting it up in your security onion, you actually be able to get it done. So if you want, you need to first, install. In this case, I'm just going to start audit D. Everyone, if you want to watch your Linux systems or your Linux containers, audit D is your good friends. Then in this case, we're going to watch the splice function of the actual attack. So if you go back to the Dirty Cow, we actually have splice function. If you read more on this documentation here, web services use the splice function to be able to write. So we're able to overwrite the root password for the system. This is what we're doing. We're using splice functions within the entire exploit. These are what we use for detection. In this case, we're already told, hey, for this exploit, these are the splice functions to watch for. In this case, we have this one and this one. The key is always going to be Dirty Pipe. So every time you run the Dirty Pipe binaries and they run the splice functions to change and modify any file. In this case, we only modified like the etc, password. We could have had Dirty Cow modify any binary and make it into an SUID. We could have done that. The splice functions will still be the same in this case. So we had 3 of them. I just added them all to audit D after installing audit D, and that actually worked. And this is how we are watching the etc password file. So this right here will actually end up in your system. So if I do audit ctl-l on my system, here's a funny thing about audit D that I don't think a lot of people will tell you. Watch what happens. That is false. This right here is fake news. I know I have audit D running, and this thing says audit ctl-d command not found. First time I did this, I was like, you gotta be kidding me. So I did this. So you're telling me audit D is running, audit CTL is not there? What are you talking about? That's the same thing. So here's to save you some headaches and to reward you for being here with me. You need to run it with sudo even if you are signed in as root. How silly is that? Like, seriously. Now you get some results. That is the silliest thing that I've ever seen. Sudo, and I'm already root. Now it tells me, oh yeah, we're watching for these splices here. We're also watching etc password. So these are the rules that you have. And you just need to put sudo every time you run this command here. Because it's an audit command, it's a privileged command. They want to make sure you're part of the sudoers group, even if you're root. Double checks. Okay, then next, they want to make sure that you can add this here. And what this is going to do is it's going to tell your host-based intrusion detection system wazuh agent that, hey, we would like you to watch this file here. So what's in that file? Let's first open that file. Maybe we should have done a tail. This is an audit file. Every time something that's within security or that's defined to be audited, this is the audit D file. So by adding this code block here, we're telling our intrusion detection system, hey, watch this location. Then we restart the agent. And after we do that, we need to tell our main wazuh agent, hey, we are watching stuff on the host over there, but we would like you to actually alert when funny stuff happens there. So we have this rule, and I can break this one down to you very quickly. You can name this whatever you want. The rule ID, the level is just a severity, I think. Then in this case, you're just looking for this SID. If it's 807 and it's coming from audit.key, then of course, in this case, these are the fields that we're looking for. The description that will print is going to be dirty cow detected. You'll notice that this one is kind of different from the one that I printed out here. I added the word previous because I wanted it to be clear. But this is how these rules work. So if you're like, hey, in security onion, where do I add this rule? Because here it tells you you need to add this to your wazuh manager. So this is on your security onion. Everything above this is on your host. Well, on your security onion, this is where you add it. I'm already signed into my security onion. You need to use nano, vi, whatever you want. Go to this location, opt, so rules, host intrusion detection system, local rules.xml. In this case, I added mine all the way at the bottom. It's the same exact rule, but you add it at the bottom. Worrying about the syntax, make sure that the indentation is correct and you do not break anything in these files. Once you do that, and if you're like, hey, I don't know how to do that, here is some documentation from Security Onion. That's where I found it. So once you do that, restart the wazuh agent, run a high state if you need to, but just restarting should be fine. And you actually end up with the rule that just fired that I was just showing you here. And that's how we can actually watch our Linux systems for the dirty pipe vulnerability. I think that this is a very interesting way of practicing. There are other ways you can be proactive about things, but at least you and I, if you watched from the beginning, now know, at least if this happened at your work or at your house, you'll actually be able to detect it because it does have some indicators that you can watch. If you have any questions, please let me know in the comments. I'm very curious what you think. But thanks for everybody who has been participating so far. BT says, if you change the SSH config file, you get caught. I think so too. I think if you start messing with the SSH config files, you might end up in a lot of trouble. You might get caught. I'm in the process of playing with Azure and Azure Sentinel and playing with a vulnerability in there. It's also fun stuff. So let me know if that's something that interests you. But right now, I'm taking any questions that people might have. To add to what we just said earlier, do you see this D package half configured here? This was me probably installing the wazuh agent on my victim. Let's watch this. This is why you probably don't want to pull too many binaries from the internet. Yeah, this was me installing things. In this case, I was installing audit D. So by installing audit D on the system, it triggered some of these noisy alerts here. So moral of the story, if you are going to hide from the defenders and you have a reverse shell on a system, the best way to do it is to make sure that, don't install a bunch of noise. It won't be an end to a live stream without showing you like, hey, let's mention the obvious here. If you do not want people to run dirty pipe on your system, just don't have any of these versions running in your system. So Linux kernel from 5.8 to 10.10.102. What that means is just go ahead and update your Linux kernels to the latest version if you can. If you're running one of these, maybe air gap them. There is an update out there that fixes this. This is only for those systems that people do not apply updates to. So if you want to protect yourself, make sure you go and apply the updates. All right, I think we are on time. Thank you very much for being here. If you joined us late, please go and watch the stream. I think this was a very, very interesting machine and also just an interesting vulnerability. And I'm happy that you were part of this journey of us learning. Join me next week at 9 p.m. Central Standard Time, and we'll have another machine as well, and we'll be learning. Who knows? Maybe next week we'll be in Azure attacking an Azure application, and I might ask you to join me in attacking it so that we can generate more logs. So see you next week, and remember to like and subscribe. Thanks for being here.